To understand the sequential probability ratio test, we take an example, that is example 1. Let x has a probability mass function f of x theta, that is theta raised to power x into 1 minus theta raised to power 1 minus x, and x is from 0 to 1, that is actually the probability mass of the Bernoulli distribution. Use the sequential probability ratio test. Let our hypothesis, that is theta is equal to 1 by 3 versus alternative hypothesis theta is equal to 2 by 3. Determine the constants C0 n and C1 n. So in first example, we just to determine the constant C0 n and C1 n. So how we proceed for this? First we have to define the likelihood ratio for the mth stage, that is actually lambda m, and that is, we know that L of theta dash m divided by L of theta double dash m, which is our general format. And keeping in view this example, that is actually L of 1 over 3 under the null hypothesis, and under the alternative hypothesis, that is 2 over 3 m. So where L of 1 over 3 m, that is actually equal to 1 over 3 raised to power some x into 2 over 3, that is 1 minus theta, that is 2 over 3, that is n minus some x. And for the other one, that is L of 2 over theta m, that is actually 2 over 3 raised to power some x into 1 over 3 n minus some x. Simple is that हमने सिर्फ Bernoulli distribution का likelihood ratio लिया है by putting their respective values of the theta, और जब likelihood रहेंगे तो वो basically binomial distribution में convert हो जाएगा. So by putting these values here in the test, that is lambda m, और जब हम इसको further simplify करेंगे, I just write down the net result, that is actually 2 raised to power n minus 2 sum xi. जब आप इस टर्म को इस पे डिवाइड करेंगे और फर्दर सिंप्लीफाई करेंगे तो वी ऑब्टेन द वैल्यू ऑफ लैम्डा m, that is actually this one. Now the inequality, that is L naught less than lambda m less than L1 becomes, that is L naught less than 2 raised to power n minus 2 sum x less than L1. Now we solve that. To solve this, we take the log of base 2 for this inequality, and we get that, that is log of base 2 L naught, which is less than n minus 2 sum x less than log of base 2, that is L1. और फर्दर इसको हम सिंप्लीफाई कर सकते हैं, दैट इज़ एक्चुअली इस टर्म को इधर ले जाएं और 2 को भी इधर ले जाएं, तो ये हमारे पास जो आ जाएगा, दैट इज़ n over 2, ये n जब इधर जाएगा n over 2 हो जाएगा, n over 2 माइनस लॉग, ये माइनस लॉग 2 L नॉट डिवाइड बाई 2 हो जाएगा, लेस देन माइनस सम x आ जाएगा, लेस देन ये हमारे पास इधर भी n by 2 माइनस log of 2 L1 divided by 2. Multiply throughout by -1 so that we can get rid of this minus. So जब throughout हम माइनस से मल्टीप्लाई करेंगे तो इनइक्वालिटीज़ जो हैं वो रिवर्स हो जाएंगी. तो ऐसी सिचुएशन में हमारे पास क्या आएगा, दैट इज़ n over 2 minus 1 by 2 log with the base of 2, that is L1, क्योंकि इनइक्वालिटीज़ रिवर्स हो जाएंगी जब माइनस से मल्टीप्लाई करेंगे, दैट इज सम x less than n over 2 minus 1 over 2 log with base 2, that is L naught. And basically this quantity actually representing the C1 of n, and this quantity basically representing the C0 n. we continue to observe the outcomes as long as that C naught n is less than some x less than C1 n. The observation of the outcome is discontinued with the first value of n for either, उस सूरत में हम डिसकंटिन्यू कर देंगे या ये सिचुएशन हमारे पास आ जाएगी कि दिस ग्रेटर देन सम x हो जाए और C1 of n is less than some x. Thus the inequality C naught n greater than some x leads to accept null hypothesis, which is theta is equal to 1 by 3, and the other inequality, which is C1 n less than some x, leads to reject h naught, that is theta is equal to 1 by 3. So that is the way how we can apply this sequential probability ratio test.